So this lesson is going to be talking about finding range algebraically. And up until now, I've said that range can only be found graphically, that we haven't had the tools yet to find range algebraically. Well, here's the exception to that. There always seems to be an exception. The exception to finding range algebraically is when we have a quadratic, and the quadratic then is in standard form. So we have 4 steps here that we're going to follow in order to find our range algebraically. So number 1 says to first put the equation in standard form into y equals ax squared plus bx plus c. Second step, you need to find the x coordinate of the vertex by using the formula of x equals opposite of b over 2 times a. That being b and 2 times that a. You're going to input this value for x into the original equation to find y, and then that will be finding the y coordinate of the vertex. Then number 4, you're going to use the y coordinate to find the range, knowing that the parabola either opens up or opens down because of the value of a. What this is saying is that if I have a parabola, and let's say the parabola has a vertex at 2, or actually at 0, 2, my apologies on that, at 0, 2, it's opening up, so there's my parabola. To find range algebraically, let's say we don't know that, we're just given a function, we don't have the graph yet, we can find it algebraically because with a parabola, we have a vertex. That vertex then we know will either be a minimum, or let's say it's opening at negative or 0, negative 2. It could also have a maximum. So if the parabola opens up, the vertex forms a minimum. If we have a parabola that opens downward, we have a vertex that is a maximum. And using the minimum and the maximum will help us find the range by saying only from that minimum and then everything to positive infinity, or starting with the maximum, we can have everything going to negative infinity to be our range. Let's put that into practice. So we have a function here that's already in quadratic, or excuse me, it is a quadratic, it is already in standard form. So I'm going to start out by finding the x coordinate by taking the opposite of b over 2 times a. A happens to be 1. Negative 4 divided by 2 is negative 2. That's the x value for the vertex. Now I need to find the y value. So I find the y value by plugging negative 2 back in to the original equation. So I take negative 2 squared plus 4 times negative 2 minus 10. Negative 2 squared is 4. 4 times negative 2 is a negative 8 minus 10. 4 minus 8 is negative 4. Negative 4 minus 10 is negative 14. So my vertex is at negative 2, negative 14. I'm going to do a little rough sketch, meaning I go over negative 2 and I go down, let's just pretend that that is negative 14. This is a positive a, which means that's going to open up. I really don't have to have a perfect sketch to get an idea of what I'm doing here, of how to find the range. So negative 2, but that means I'm going down negative 14 on the y-axis, so that I know that my range is going to include negative 14 and go all the way to positive infinity. Finding the range algebraically. Let's look at the second one. X equals, I'm already in standard form, so the opposite of b will be 5 times 2 times a. A happens to be 3 here. So I have 5/6 is my x value. I'm going to plug the 5/6 into that equation, into the original equation, and I get y equals 3 times 5/6 quantity squared minus 5 times 5/6 plus 4. Giving myself a little work room here. I'm going to square my fraction. So I get 25/36 minus 25/6 plus 4. I know that 3 can go into 36 12 times, so I'm going to just simplify that. So I get 25/12 minus 25/6 plus 4. Getting a common denominator of 12 means I'm going to multiply this fraction, both numerator and denominator, by 2, and this whole number by 12 over 12, which leaves me with 25/12 minus 50/12 plus 48/12. Adding all of that together, I get 23/12. So that's my x for my vertex is 5/6. My y is 23/12. Could you have done that on your calculator, getting a decimal? Absolutely. But let's exercise our brain a little bit. And so I know that's a positive. So my parabola would be a positive opening up. My minimum, I know I'm looking at the y value because I'm looking for range. That's a minimum. So therefore it's everything up. So I go, that's included, so I have a bracket, 23/12 to positive infinity. And then our last one we have, again, it is already in standard form. So finding my x value, I say x equals opposite of b over 2 times a. So I get -7 over -4, which becomes a +7 over a positive, I'm sorry, not a +7, but you've got a negative being divided by a negative, which makes that entire fraction positive. I take my 7/4, plugging it back into my equation, and I've got -2 times 7/4 quantity squared plus 7 times 7/4 minus 14. Again, giving me some space here, working with fractions, exercise our brain here. So we get -2 times 49/16. Now just a reminder that when we square a fraction, both numerator and denominator get squared. Plus 49/4 minus 14. -2 can go into 16 a -8 times. That leaves me with 49 -49/8 plus 49/4 minus 14. Getting a common denominator of 8 means on this fraction I'm going to multiply both numerator and denominator by 2, and on the 14 I'm going to multiply by 8 over 8 to get that common denominator. So I end up with -49/8 plus 98/8 minus 112/8. Seriously? Gives me a -63/8. So my vertex, my x value was 7/4. That's what started all this madness. And my y value is -63/8. Doesn't your brain feel so healthy? And my vertex, or excuse me, my a is negative, which means the parabola this time is going down, facing downward. So that means that my y value is a maximum. So that means it's going to start with -infinity and end with -63/8 inclusive. That is how you find your range algebraically.